Hi, and welcome to the Actual Tech Media Expert Series. I'm Keith Ward. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event on protecting Microsoft environments, how to defend Azure and on-premises infrastructure. But before we get to today's content, we do have a few housekeeping items that'll help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during this live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that come in. That Q&A panel is also the place to just say hello, which a lot of you have been doing already. We love to hear where you're logging in from. And it's also the place to let us know if we can help in the unlikely event you have any technical issues. A browser refresh will fix most issues, but if that doesn't work, let us know in the Q&A and we'll provide further technical assistance. At the end of this webinar event, we'll be awarding a $300 Amazon gift card to a registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handouts section. Scroll to the bottom and you'll find the prize terms and conditions link there. Now, these expert series events are special product neutral looks at pressing technology problems presented by an expert in the field. But the support of our sponsors make it possible for us to bring you this content. So we want to give a special shout out to our sponsors today. Over the next few slides, I'm going to share some messages from our sponsors today, and they'll refer to links that you can find in the handout section of your console at any time during the presentation. As always, the handout section also has some valuable Actual Tech Media links. There's a link to the Gorilla Guide Book Club where you can get access to Actual Tech Media's great printed resources on technology topics. There's also a link to the ATM Events Center, which has our calendar of upcoming events. Now, before we get into the main presentation, a few words from our sponsors. We are supported by Veeam. Now, Veeam's latest releases of Veeam Backup and Replication V12 and Veeam Backup for Microsoft Azure V5 feature new capabilities to store backups in Azure Blob using worm state, standing for write once, read many. This ensures data can't be modified or deleted, features that, as you know, are critical to compliance and recovery from cyber attack. Today's event is also sponsored by Rubrik. Now, companies around the world rely on Rubrik, the pioneer in zero trust data security for business resilience against cyber attacks, malicious insiders, and operational disruptions. Rubrik Security Cloud, powered by machine intelligence, enables their customers to secure data across their enterprise, cloud, and SaaS applications. Rubrik automatically protects data from cyber attacks, continuously monitors data risks, and quickly recovers data and applications. Today's event is also brought to you by CyberArk. Take control over unmanaged privileges on endpoints. CyberArk helps you resolve your biggest endpoint security vulnerability with CyberArk Endpoint Privilege Manager, or EPM. With EPM, you can remove local admin, enforce role-specific least privilege, and defend credentials. You can also multi-platform endpoint privilege management, including Windows, Windows Server, Mac OS, and Linux. So, with all of that, take advantage again of that handout section where you can find all the links that you've just seen for our sponsors today. So now let's move on to today's content. It's my pleasure to introduce to you our presenter today, who is Brian Posey. Brian's a prolific author who I've actually worked with for many years. He's written, I don't know how many articles for me over the years, and he is just such an expert, and we're delighted to have him. Now, Brian has authored, co-authored, or contributed to more than 50 books and has created more than a dozen video training courses. These are in addition to his 7,000, actually more than 7,000 articles and papers, and he also routinely speaks at various IT-related events. You could definitely say that Brian is an expert in his field. He's also in training, interestingly enough, to be a commercial astronaut. So this is a guy who is truly a Renaissance man, and we are just so excited to have him speaking today. So at this point, I'm going to turn it over to Brian for his presentation for us. So Brian, you can go ahead and take it away today.
Hey, thanks a lot, Keith, and thank you for that awesome intro. I really appreciate it. So hello, greetings, and welcome, everyone. So today I'm going to be talking about defending Azure on-premises and infrastructure. So I'll go ahead and skip the bio slide because I don't think I could possibly do justice to the intro that Keith already did. And let's go ahead and get into the content. Now, the whole idea behind this presentation is to talk about various ways that you can defend all of your Azure resources and your on-premises resources. Now, before I really get into this, I need to talk about one big thing, and that is that Azure is huge. I mean, let's face it, Azure contains over 200 services, and on-premises environments can be equally complex, if not more so. So, being that I've got less than an hour to speak, there's no way that I could possibly turn this into a comprehensive discussion on every available option for securing Azure and your on-premises environment. So that being the case, what my goal is for this particular presentation is to just give you some things that you should be thinking about for both environments. I'm going to begin by showing you some areas where you might want to initially concentrate in an effort to reveal vulnerabilities that may exist and some things that might potentially need your attention. And then from there, I'm going to jump into a few security best practices for both environments, and I'll show you a few mechanisms that you can use to enhance your security efforts. So that's just kind of a high-level overview of where I'm planning on going with this presentation. So with that said, let's go ahead and get into it. So the very first thing that I need to talk about is the shared responsibility model. Now, the shared responsibility model is something that generally all cloud providers have. It's based on the idea that there are certain things that the cloud provider is responsible for, but there are also things that the subscriber or the customer is responsible for as well. And every cloud provider that I know of has some sort of shared responsibility model. What it usually breaks down to is that the cloud provider is responsible for maintaining the underlying infrastructure, whereas the customer is responsible for their own data and for using the available security mechanisms to keep that data secure. Now, the thing that I found interesting about this chart that's shown on this slide is that Microsoft has finally gone through the step of formalizing their shared responsibility model. I mean, they've talked for years about having a shared responsibility model, but I had honestly never run into a chart like this until just a few weeks ago. I'm not going to go into this chart in super granular detail because there's a lot more content that I want to get to, but I do want to point out a few things about this chart, and this is something that I would encourage you to come back to later on if you're not super familiar with this model. Now you'll notice that there are 4 columns of blue boxes. The print is a little bit small. I know it might be hard to see on some of the devices that you're using. The first column is SaaS, the second column is PaaS or Platform as a Service, then we have Infrastructure as a Service, and then On-Premises. So if the box is blue, it means that it's the customer's responsibility. If it's gray, it means that it's Microsoft's responsibility. And if there's a triangle in the box, it means that it's a shared responsibility. Now, the categories of boxes are divided into 3 main categories. Responsibility always retained by customer, responsibility varies by service type, and responsibility transferred to cloud provider. So what you'll really get by looking at this chart is that things like physical host, the physical network, the physical data center, those are all things that the cloud provider generally takes care of. Now, in an on-premises environment, which is the row boxes on the far right, the customer is obviously responsible for everything. But even in a cloud environment, there are certain things that the customer is responsible for. Generally, it's going to be things like information and data, your devices, things like the mobile devices that your users work from and their PCs, and their accounts and identities. And then there may be some other responsibilities as well, depending on which type of cloud you're working with. But this is the essence of Microsoft's shared responsibility model. And the reason why I'm showing this to you is that it's really hard to know where to focus your security efforts in Azure until you really know what your responsibilities are versus what Microsoft is already doing for you. So, okay, let's say that you've gone through this chart, you realize, okay, I need to secure my own data, I need to secure my user identities, certain devices. Where do you go from here? Well, in an Azure environment, where I would recommend that you start is by paying a visit to the Azure Security Center. And a lot of the Microsoft documentation refers to this as Azure Secure Score. And what this is it's just a page within the Security Center in Azure that gives you some recommendations on some things that you can do to improve your environment's security. And what I really like about this particular interface is that it's categorized based on risk. So if you look at this particular screen capture, you can see that there are 6 high security risks, or high severity risks rather, 1 medium risk and 3 low risks. The print's a little small on my monitor. And then just beneath that summary, you can see what the recommendations are. So the very first recommendation on the list is that multi-factor authentication should be enabled on all accounts with owner permissions and on subscriptions. Then beneath that, there should be more than one owner assigned to a subscription, which is a good idea because if something were to happen to the person who set up the subscription, then you could potentially lose access to the subscription or get locked out, or any number of other bad things could potentially happen. So Microsoft is giving you some very practical recommendations right here in the Azure Security Center. Now, this isn't the only source of recommendations that are available within Azure. Once you've taken a look at the Azure Security Center, then the next thing that I recommend doing is taking a look at Identity Secure Score. And if you look at the tabs on the left side of the slide, you can see in the Manage section, Identity Secure Score is the very first option that's presented. And you can see what the Identity Secure Score looks like right here. Now, before I get into the Identity Secure Score, 2 things that I want to quickly mention. One is that there's typically going to be some overlap with the information that's presented in the Azure Security Center. And also, if you subscribe to Microsoft 365, there is a very similar secure score that's presented in the Microsoft 365 environment, but a lot of the recommendations that exist for Microsoft 365 are separate from what you're going to find with Identity Secure Score. So having said that, let's talk about how this works for anybody who might not be familiar with this particular interface. The biggest thing on this particular slide is a numerical score, in this case 14.29%, which, to be perfectly honest, is a really bad score, but this is a lab account, so it doesn't truly matter. The score reflects the percentage of security items that you've implemented based on Microsoft's best practices. So down in the lower portion of the slide, you can see a list of improvement actions, kind of like what we had in the Azure Security Center. And each one of these improvement actions has a score impact that's associated with it. So as you implement one of these actions, you can see how much you expect your score to go up. Now, the goal here is to get a high score, obviously, but it isn't all about getting a perfect score because there are a few different things to think about here. One thing to think about is that some of these actions are going to yield you a bigger score improvement than others. So items that have a bigger score improvement are generally higher priority items. They have the biggest impact on your organization's security. So those are the types of things that you should probably start with. But it's also important to balance security with usability, because not every recommended action is going to be appropriate for every organization. So you don't want to go in and perform a security action just because the Identity Secure Score tells you that doing so is a good idea. It's more important to consider, is this action right for my organization, rather than just blindly implementing an action. Another thing to think about is the user impact, and that's sort of what I was alluding to just a moment ago. The second column from the right is the user impact, and the items are categorized as having a low impact, a medium impact, or a high impact. So an item with a high impact is something that's going to be really visible to a user, and it may even change the way that the user has to do certain things, such as signing in. Whereas a low impact item is something that the user's probably not even going to notice. And then in the column on the far right, we have something called implementation cost. And this is another really important thing to pay attention to, because some of the items that are on this list can be done without incurring any additional cost. Other items on the list might require you to get an Azure AD Premium P1 or P2 subscription. So sometimes there are costs associated with these security items. So you have to consider all of these various things when deciding where to focus your security efforts. So let's get into some security best practices. One of the big security best practices that Microsoft makes for Azure virtual machines is to turn off RDP. Now, on the surface, this sounds absurd because RDP is the very thing that a lot of organizations use to manage their cloud-based virtual machines, and even some of their on-premises virtual machines, whether they're running on Hyper-V or VMware or some other platform. But the reason why Microsoft recommends turning off RDP is simply because RDP is something that attackers commonly use as an attack vector. And it's also something that tends to be more of a convenience item than a necessity. Because if you think about it, imagine you've got 1,000 virtual machines. You're probably not RDPing into all of those virtual machines every single day to perform management tasks. Often management at scale is going to be done using other tools such as the Windows Admin Center or PowerShell or something like that. It's relatively rare to have to RDP into a virtual machine and perform some sort of management tasks. Certainly that is something that has to be done from time to time, but it's probably not something that most organizations are doing every day. So Microsoft's best practice is to go ahead and disable RDP, especially for your Azure virtual machines, and then just re-enable that on an as-needed basis. And it is possible to disable RDP and to re-enable it without actually having to RDP into that virtual machine to do that. So let's take a look at how that's done. Oh, and incidentally, before I move on, another option is to remap the port that's used by RDP. RDP by default uses port, I believe it's 3389. At one time, that was an effective security measure, but port scans have kind of rendered that obsolete. There really isn't a lot of point in remapping the RDP port because an attacker can very easily discover what port number it's been remapped to. So how do you disable RDP? Well, to do it from PowerShell, you would use the set item property commandlet, and then you would set the path to hklm:/system/current control set/control/terminal server. That's a registry path, obviously. And then -name, fdeny ts connections, and you would set the value to 1. So by setting that value to 1, what you're effectively doing is denying terminal service connections to that particular virtual machine, which is what RDP uses. And then once you've done that, you can also use the disable net firewall rule commandlet to disable firewall rules related to remote desktop. Now, incidentally, it's a little bit outside of the scope of the discussion that I wanted to present, but one thing I did want to quickly mention before I move on is in that very first commandlet, you'll notice that we're using set item property and we're pointing the path at the Windows registry. The set item property commandlet isn't the only PowerShell commandlet that you can direct at the Windows registry. There are a lot of PowerShell commandlets that are typically used to navigate the file system, but those same commandlets can very often be used to navigate the registry the same way that you would navigate the file system. For example, the getChildItem commandlet retrieves the directory of the folder that you're looking at, but that same commandlet can also be used to query the registry. Just something I wanted to throw out there. So anyhow, let's suppose that you've gone in and you've disabled RDP from all of your Azure virtual machines, and maybe even all of your on-premises virtual machines. And then something happens and you need to RDP into one of those virtual machines. What do? Well, you can re-enable RDP on that particular virtual machine the same way that you disabled it. What you do is you open up a PowerShell session and use the set item property commandlet, and it's the exact same command that I showed you on the previous slide. The only difference is that instead of assigning a value of 0, we're assigning a value of 1. And then with regard to the Windows firewall, instead of using the disable net firewall rule commandlet, we're using the enable net firewall commandlet. Everything else is the same. Now, if you look at the slide with the screen capture, you'll notice that I'm doing this on a local machine. If you're trying to disable or enable RDP on an Azure virtual machine or on a virtual machine that's running on a Windows server in your data center, you're going to first need to establish a remote session. And there are a few different ways that you can do that. One option is to use the new-ps session commandlet and then specify the name of the computer that you're connecting to. Another option is to use the invoke command commandlet, and then again you would use the computer name parameter and specify the machine that you're connecting to. Now, a couple of caveats that you need to be aware of with regard to using these commands. One of those caveats is that the commands, the way that they're written on the slide, assumes that you have DNS name resolution for the machines that are specified. So if you can't do DNS resolution for those particular machines, you may want to provide a fully qualified domain name or an IP address or some other means for identifying that remote system. The other caveat is that The way that the slides are written, they assume that you've already got the credentials that are needed in order to connect to those remote machines. If you don't have the credentials already, then you're going to need to supply those. And generally, the way that that is done is by mapping a set of credentials to a variable in PowerShell. The way that I typically do it is by setting up a variable called $cred, short for credential. You can really call the variable anything that you want, but you set that equal to get credential. Get-credential is a PowerShell commandlet. And when you do that, what you're going to get is a pop-up box that prompts you to enter your username and password. Once you've entered that, then that gets mapped to the variable that you've specified. So then when you use a command like new PS session, you can append a parameter, I believe it's called credential, and then follow that up with the variable that is storing your credential, and then that will gain you access to the system that you're trying to connect to. So let's go ahead and move on. Now, I mentioned disabling RDP. There are several other ports that are frequent targets by attackers. Some of those ports are the FTP port, which is TCP port 21, SSH, Telnet, HTTP. I've often heard of HTTP referred to as the universal pass-through port, simply because so many software providers try to pass things through port 80. LDAP, HTTPS, SQL, and of course RDP. These are all things that are favorited by attackers. Now, I'm not telling you that you should lock down all of these ports, because sometimes these ports have very legitimate uses, and your business use case may mean that you simply cannot block those. But if you are leaving any of these ports open, it's important to at least be monitoring those ports just to make sure that nobody's going in and trying to attack your servers. So that raises the question of, how do you know if your server is under attack? Well, there are a few different ways. The best option is probably to use Azure Defender, which used to be known as Azure Security Center, or there are a lot of really great third-party monitoring solutions out there. You could certainly use one of those. Another option is to use PowerShell. And there are a lot of different things that you could look for in PowerShell, but one of the more effective things to look for is failed login events. Because, certainly you could use PowerShell to search for port scans, but that only tells you that somebody is probing your server. It doesn't tell you if somebody's actually trying to log into that server. So I like looking for failed login events. It's super easy to do. Let's take a look at how that works. So the way that you would look for a failed login event is to use the get event log commandlet. Now the get event log commandlet can be used to query any of the classic PowerShell logs. That's the security log, the system log, the ones that have been part of Windows forever. If you're trying to query any of the newer event logs, there's a different commandlet that you have to use. I believe it's get when event or something like that. So anyway, you use get event log because the security log is one of the classic event logs. Then you have to use the log name parameter. In this case, we're querying the security log because the security log is where login events are stored. And then we have to know the event number that we're querying. Now, for whatever reason, PowerShell refers to this as the instance ID rather than the event ID. So the instance ID parameter is what you would use to specify the event ID. And the event ID that's associated with a failed login request is 4625. So when you run this commandlet, you will typically get an output that's similar to what you see on this screen. Now, if you were to see output that was identical to what's shown here, this probably isn't cause for concern because you've got two failed login attempts that happened back to back. They both occurred at exactly the same time. Something like that probably just indicates that a user was trying to log on, they typed their password wrong, and they tried again, typed it wrong, and then they eventually either gave up or got it right. So if I saw two failed login events, I probably wouldn't be overly concerned. If, on the other hand, I entered this command and I saw hundreds and hundreds of failed logon events, that might raise some red flags. And incidentally, I'm not going to go into it over the course of this presentation because there are quite a few other things that I want to talk about. But let's say that you enter this command and you get a great big long list of failed login events. That in and of itself doesn't necessarily mean that you've got a problem. And the reason for that is because those hundreds and hundreds of failed login events could span a considerable length of time. So if all of those failed login events are spread out over several years, you may not have a problem at all. So what I would recommend doing in a situation like that is using a filter at the command line level and filtering based on date and time. So that way you can take a look at recent failed logins, so you can find out, okay, all of this massive list of failed logins, are they distributed over a long period of time, or did these all occur yesterday? Because that's a very important detail if you're trying to figure out if you've got a problem or not. So what else can you do? Well, one of the things that I would recommend doing if you're interested in securing your Azure AD, or excuse me, your Microsoft Azure and your on-premises environment, is to take a fresh look at your password policy, because passwords are really vulnerable to attack, especially in cloud environments. So if you're still using passwords, then I would recommend focusing on length and complexity, not on change frequency. A few years ago, Microsoft updated their best practices to reflect that you shouldn't force users to change their passwords unless there's a compelling reason to do so. The old policy of change your password every month or every 90 days or what have you, Microsoft no longer recommends doing that. And there are several other security agencies, including NIST, that also no longer recommend forced password changes. And the reason for that is really simple. If you're requiring really long, complex passwords and you require users to change those passwords frequently, well, most people aren't going to be able to remember all of those password changes. So they're probably going to resort to doing things like writing the passwords down, which can undermine the very security efforts that you're putting into place. So it's a lot better to go ahead and just require those complex passwords, but not force users to change it unless a password has been compromised. Now, the subject of compromised passwords is something that we really need to talk about, because you can buy compromised passwords on the dark web. There are literally billions of compromised passwords that are available for sale. I've seen databases out there that claim to have over 2 billion compromised accounts. And from what I've heard, that number is actually closer to 3 billion now, but I can't personally verify that. So why does this matter? Well, there are a couple of reasons. First of all, if a user's account has been compromised, then that compromised account's credentials are probably for sale on the dark web somewhere. But let's suppose for a moment that you've got a user who has an account with a relatively strong password, and that account has never been compromised before, but just by random chance, you've got somebody somewhere else in the world who created an account with the exact same password as what your user has, and their account has been compromised. That could be a problem for you, even if the user name is completely different. So why is that? Well, consider what it takes to brute force crack a password. Assuming that the password is relatively long and complex, it can take a super long time to brute force crack a password. If the password's 8 characters, you can get through that fairly quickly. If you've got a 20-character password, even with today's resources, it's going to be completely impractical to brute force crack that in a reasonable length of time. The reason why it matters is because once a password has been compromised, then oftentimes that password is just hashed, and the hash is added to this database that I mentioned with all of the compromised passwords. So rather than having to brute force crack a password, you can simply look up its hash. So if a user is using a password that's identical to somebody else's password that has been compromised, that password becomes vulnerable simply because the hash matches. And an attacker wouldn't have to use a brute force crack to figure out what that password is. They could simply hash the password and then do a database lookup to see if there's anything in the database that matches the hash of that password. And if a match does exist, then they can very easily determine what the password is. Okay, so let's talk about a few other password-related best practices. In my mind, organizations should look to try to move away from passwords if they can in favor of biometric authentication, because that's going to be more secure than passwords. For the time being, though, most organizations are stuck using passwords simply for compatibility reasons. So let's say that that's you. You're still using passwords. You're going to continue using passwords for the foreseeable future. What can you do to make those passwords more secure? Well, one thing that you can do is to enable self-service password resets. Self-service password reset is a capability that exists within Azure Active Directory. It's not something that you have to go out and buy, although there are some really good third-party products out there that will do this. Self-service password reset can help you to avoid breaches that are related to the password reset process. So let's take a look at what that looks like. So here I am in Azure Active Directory, and you can see that I went to the Manage section and selected Properties. And then there's an option here for self-service password reset enabled. And we have three options: none, selected, and all. If you choose all, then self-service password reset is going to be enabled for all users. If you select none, it's not going to be enabled for anybody. And if you choose selected, then you get to choose the groups to which self-service password reset will be available. Now, the way that this works is that you have to provide some authentication methods to be used during the self-service password reset process. So once enabled, the user will go in and register for self-service password reset. And typically what this registration process looks like is that the user will have to maybe register their mobile phone number. They might be required to answer a number of security questions. They may have to provide their email address. It's really up to you what that registration process looks like. But if you look at the last two options on this slide, under security questions, you don't have to enable the use of security questions, but if you do, you can choose how many questions the user has to enable in order, or how many questions the user has to answer in order to complete the registration process. But then there's a separate option for the number of questions that the user has to answer correctly in order to reset their password. So what some organizations will do is they'll require the user to answer 5 questions to enable their account, but they'll only prompt the user for 3 of those questions during the password reset process. So that way the user doesn't really know what's coming. You can also force the user to register when they first sign in, and there's also an option in there to reconfirm authentication number every 6 months or whatever time period you specify. And that's really important because you could end up in a situation where you have a user who never ever forgets their password, and one day, several years after they've initially signed up for self-service password reset, they forget what that password is, and then none of the registration information that they entered way back when is even current anymore, so they have no idea how to reset their password. So reconfirming that authentication information every 6 months or every year or whatever time period you decide is appropriate can be an important step in just making things a little bit easier on your users. And from an end user experience, let's say a user does forget their password. What they have to do is go to a designated website, and I believe that website may have been listed on the one of the previous slides. Yes, it's at the bottom of the slide, https://aka.ms/sspr setup, SSPR being self-service password reset. So the user would go to this site, and then they'll see an interface like this. They're prompted to enter their username or their email address. They complete a CAPTCHA and then click Next. And then they'll be prompted to complete the identity verification process. And that process is going to work differently depending on which methods you have required them to use. So if, for example, you've enabled mobile phone and security questions, then the user would receive a code on their smartphone that they'll have to enter, and then they'll also be required to enter their security questions. So why does the whole self-service thing even matter? Why not just let users do the old thing of contacting the help desk and asking for a password reset? Well, there are a few different reasons. One is that password resets are inconvenient. I mean, if you have to call the help desk, you have to take time out of what you're doing, place a phone call, you might be put on hold for a while the help desk deals with somebody else, or somebody else who has a real problem might have to wait until the help desk helps you with a password reset until they can help the person who really needs help. It's also potentially embarrassing. In the early part of my IT career, I worked help desk, and there were users who were just utterly petrified of calling the help desk asking for a password reset because they would inevitably get that question, hey, didn't I just reset your password this morning or yesterday or something like that? So there are some users that are embarrassed about chronically forgetting their passwords. More importantly, though, the whole password reset process is only as secure as the technician who is completing that request is trustworthy. So if you've got a shady help desk technician, then that password reset process might not be so secure. Because think about the way that this process normally works. Let's say a user forgets their password, they contact the help desk, And then the help desk technician sets out to verify the user's identity. And let's say that they do this using the same method that I just talked about with self-service password reset. First, they send a code to the user's mobile device, and the user tells them what that code is. That's certainly a good option. But one thing to keep in mind with that is that if someone has stolen the user's mobile device and is impersonating that user, then this doesn't really help you a whole lot because they're in possession of the device that receives the code. So you don't truly know that user is who they claim to be simply based on that code, unless you just happen to recognize their voice or something like that. So the next thing that might happen is that the help desk technician might ask the user a security question. So the user answers that question and the technician resets the password. The problem is that at this point, that technician knows the answer to that user's security question. And if you really stop and think about it, there are countless online services that all use more or less the same types of security questions. So if you've got a help desk technician who has bad intent, they could potentially compile a list of user security question answers and then use that for bad purposes. They might turn around and sell that information or use it to compromise the user's online accounts outside of the organization. Who knows what they would use it for? So that's why self-service password reset is so important. Now, I talked a little bit about multi-factor authentication. Multi-factor authentication can come in a number of different forms, and this is one of the big recommendations that Microsoft makes regarding locking down Azure or Microsoft 365 or any of their online services, is to use multi-factor authentication. Typically, when people talk about multi-factor authentication, they're referring to smartphone-based multi-factor authentication, where a code is sent to a smartphone using an SMS text message. That's certainly not the only form of multi-factor authentication, but for the purposes of this discussion, that's the form that I'm going to talk about. There are a few things that are important to keep in mind with regard to multi-factor authentication. Microsoft recommends it heavily. There are even online articles in Microsoft Learning where they claim that multi-factor authentication will prevent the vast majority of attacks against user accounts. The actual statistics kind of vary from one article to another. I've seen, trying to think, I've seen some articles that use numbers as low as 70% of attacks being prevented. I've seen other articles that state that up to 99% of attacks can be prevented against user accounts by using multi-factor authentication. I'll leave the actual number up to you. I'm not quite sure where I stand on this, other than that using multi-factor authentication will help to improve the security of your user accounts. But there are some things that you have to be careful about with regard to using multi-factor authentication. First and foremost, avoid the temptation of applying blanket MFA policies. What I mean by this is taking a look at Microsoft's recommendations and saying, well, Microsoft recommends multi-factor authentication, so we'll just turn it on for everybody. That's generally the worst thing that you can do. And the reason for that is that there are some accounts that simply will not work with multi-factor authentication. Let's suppose that you use a service account for a particular application. Well, that service account completes an automated logon, and it's not going to be able to enter an MFA challenge. So if you require MFA for that account, you're probably going to prevent that application from running properly the next time that application is rebooted. Also, a lot of organizations will set up one or more break glass accounts. A break glass account is an account that's to be used only in a dire emergency. Typically, what an organization will do is they will create one or two accounts that have access to absolutely everything and have no restrictions whatsoever associated with that account. They'll assign the account a super strong password, and then they'll lock that password away in a vault, never to be used again unless a dire emergency happens that cannot be fixed any other way other than using that account. Well, if things have gone so badly in your organization that you're having to use that break glass account, you really don't want that account to be constrained in any way. And applying an MFA policy to that account can actually, in the right circumstances, prevent that account from being used when it's the very thing that you need in order to overcome an emergency situation. So be careful not to apply an MFA policy to your break glass accounts. And there might be other types of accounts in your organization that also should not have MFA policies associated with them, particularly if you have accounts that are used by IoT devices or things like that. Now, another thing that I wanted to talk about with regard to multi-factor authentication is that even though a lot of organizations will talk about multi-factor authentication as being something to make your organization super secure, MFA can be beaten, particularly when we're talking about um, codes being sent to a smartphone in the form of an SMS message. Now, the easiest way to beat a multi-factor authentication challenge is to simply steal the smartphone. Um, Once you've done that, assuming that the phone isn't locked, it's easy. But let's suppose that a user is in possession of their own smartphone and an attacker wants to compromise that user's account even though that account is guarded with multi-factor authentication. How might they do that? Well, let's take a look. Now, I know the slide is a little bit busy, but I want to take a few minutes and go through this. So the very first thing that an attacker would do is they would set up a website that mimics a legitimate portal, something that the user would ordinarily use. And this is easier to do than what it sounds like. Because think about the way that a web browser works. A web browser goes in and it downloads HTML code associated with the site. It also downloads any pictures that belong to the site and things like that. And open your browser, go to any site you want, and do the view source option. Typically, I believe it's the F12 key, and that will show you the source code for the site. Well, an attacker can copy that code over to their own web server. They can copy the pictures associated with that site, and they can create a dummy site that looks exactly like the site that they're impersonating. It can be difficult to tell the difference. Then what they do is they register a domain name that is similar to the legitimate domain name or something that is a little bit different but isn't going to raise too many eyebrows, and then they send out phishing messages to direct somebody to connect to their fake site instead of connecting to the real site. So that's where the attack begins. That's step one. So let's say that you've got a user on your network who receives one of these phishing messages and totally falls for it and thinks that they are going to be logging into your portal, when in reality they're going to be logging into the attacker's fake portal. So what happens then? The user clicks on the malicious link, they connect to the fake site. That's the site that's shown in black in the center of the slide. So that's step two. So step three is that the user enters their credentials, but then that fake site ends up sending those credentials to the real site. So the real site receives those credentials and says, okay, a user is trying to log in. Oh, that account is protected with MFA, so we better issue an MFA challenge. So at that point, the real site sends an MFA challenge to the user's smartphone. The user, remember, thinks that they're logging on to the real site, so the MFA challenge that they receive on their smartphone is totally expected. So the fake site that the user is connected to provides a box where the user can enter the code that they received through SMS text messaging, and that code was generated by the real site. So the user types in that code, and then the fake site relays that code over to the real site, and at that point the fake site has gained access to the real site and the user is none the wiser. So by using a method like that, even though it's a little bit complicated, an attacker is able to completely circumvent multi-factor authentication and gain access to a portal site using a compromised account without the user being any the wiser. So all of this is just to kind of underscore the idea that MFA is important, and it's certainly something that I would recommend turning on for your general user accounts and definitely for any privileged accounts in your organization, but it's not the be-all end-all when it comes to security. MFA can be beaten. So what else can you do to enhance the security of your Azure environment and your on-premises environment? Well, another thing is to adopt a solid patch management strategy. And I don't want to go too much into this thing because patch management is one of those things that's been discussed over and over and over again by so many people. And there's probably not a lot that I can add to that discussion, but I want to at least mention it because it is so important. So with regard to patch management, my advice would be don't rely solely on Windows Update. Yes, Windows Update works. Yes, it will download the latest patches. But it's best to maintain centralized control over the patch management process, whether you're using WSUS or a third-party solution. It's just best to be able to centrally manage that patch management process. And if you are using a third-party solution, make sure that you're using something that supports more than just Microsoft products, because Microsoft isn't the only software company out there that sends out updates. Pretty much everybody sends out updates at this point. So it's a good idea to have a multi-vendor solution in place. Also, make sure that whatever solution you're using has a good reporting engine built in, because you want to be able to identify systems that are missing key patches or that are having problems with the update process. Every once in a while, especially on Windows networks, you'll find that there might be certain clients that have problems that prevent them from receiving updates. I've seen that more times than I can count. And so if you just leave patch management to chance, then those particular systems may go a really long time without ever being updated. When, if you're using a reporting mechanism to identify those, you can figure out which systems are having the problems and then go in and fix those problems so that those systems will once again be updated the way that they need to. Also, while we're talking about on-premises systems, another bit of advice that I would pass around is to make sure that you're periodically updating gold images that are used to deploy Windows Server or that are used to deploy your desktop operating systems. And there are a couple of reasons for that. One reason is because your system is vulnerable to any patched vulnerabilities until the patches for those vulnerabilities have been applied. So let's say you've got a Windows Server build from last year and you're using that to set up new servers, but critical vulnerabilities have been discovered since the time that build was created. Well, every time you set up a new server, that server remains vulnerable until it is patched. Whereas if you periodically go in and you create a brand new deployment image, then the patches for those vulnerabilities are already built into that image, so the system's a lot less vulnerable. The other thing, or the other reason why I recommend going ahead and periodically creating new deployment images is because there are certain security features that only work in clean deployments. And the main example of that is in Windows 11 build 22H2, Microsoft introduced a feature called Smart App Control. What Smart App Control does is it will automatically block applications that Microsoft considers to be malicious. Think of it as a next generation replacement for AppLocker. Now, there are a lot of advantages and disadvantages to using this particular feature. I'm not really here to debate its merits, but the one thing that I do want to talk about before I run out of time is that if this is a feature that you want to use, and I tend to lean more towards using it rather than not using it, but if this is a feature that you want to use, it can only be enabled on brand new Windows deployments. So if you've got an existing Windows deployment and then you install version 22H2 as an upgrade, you're not going to be able to turn this feature on. The option to enable this feature isn't even displayed within settings. So you have to have a clean installation in order to use this feature. So that's just an argument for going ahead and periodically creating brand new deployment images rather than just relying solely on the update process to bring all of your systems up to date. Is because there may be features like that that you want to use, but you can't use if you're simply patching systems rather than doing clean installations. So with that said, there are quite a few other slides, but I know I'm rapidly running out of time here, and I do want to leave a few minutes for question and answer. So I will go ahead and turn it back over to Keith.
All right. Thank you, Brian. That was just great, timely information. I think especially the multi-factor authentication not being foolproof. For me, it was an eye opener, and and according to some of the questions we got, I think others may have kind of felt the same way. It's one of those things that you think it can sort of lull you into a false sense of security, can it? Thinking, well, I've got MFA, now I'm safe. I have nothing else to worry about. Would you agree with that?
I would absolutely agree with that. And one thing that I would add to that statement is that IT pros tend to think in terms of checklist with regard to security. And I know I myself am super guilty of this. So I'll definitely put myself out there like that. And what I mean by checklist is we've all read, and in my case, written articles like, hey, do these 10 things and aren't you going to be secure? Well, the attackers don't care about those checklists. They're not going to base an attack on checking to see if you've done this, that, or the other. What they're going to do is take the graph approach. Okay, right now I'm here. I'm trying to get here. What steps can I take to get me there? So they use a totally different approach. And so if you've enabled MFA, that's great. I'm certainly not trying to discourage anyone from doing that. But just keep in mind that that's not going to block all attack vectors. An attacker is simply going to look for another way of getting to their objective that doesn't necessarily be, or that won't necessarily be thwarted by the existence of MFA.
Yeah, absolutely. Absolutely. So Joseph wants to know, related to that, um, can we expect a new technology to supersede MFA? He mentions biometric technology integrated with the device they're logging in to verify, that it's the correct identification, the correct login. Do you think that's coming?
Oh, I absolutely think that's coming. I think that's the next logical step, because really the key to making MFA work is to have multiple forms of identification. I mean, that's the very essence of MFA. But simply sending a code to a smartphone is no good because a smartphone can be stolen, and if it happens to be unlocked, then the attacker is going to get the MFA prompt. But when you're doing MFA, you're sending with biometric authentication. You're not only sending a challenge to a smartphone, which is one form of identity because you're in possession of that device, presumably. But if you also have to provide a fingerprint or a retina scan or some other form of biometric authentication, that's really a second form of identity verification right there. So I think that's what the future truly holds for MFA is um, what I think of as compounded MFA, where you're using more and more forms of identity challenges, all brought together to prove positively establish someone's identity.
For sure. Jeffrey wants to know then, given everything that we've talked about that you've presented on MFA, is it better to disable legacy authentication protocols that are already on the network?
That's a really interesting question. Microsoft, if you go in and you read their security best practices, they absolutely recommend disabling legacy authentication protocols. Um, Having said that, though, you may find that you're not able to do it because if there are certain legacy applications that still depend on those, uh, you may have users that are working from certain types of devices that still depend on those legacy authentication protocols, especially if they're using an app to access whatever resource it is that's protected by that authentication mechanism. So if you're able to, then yes, I would say absolutely go in and disable those legacy authentication protocols. But just know as you do that you may end up having to turn them back on if it ends up breaking something.
Sure, sure. Okay, great. Couple more questions I think we have time for. Steve wants to know, is an MFA such as Duo better because it requires you to accept uh, versus entering a code? Different way of looking at it and maybe really useful.
Um, Unfortunately, I don't really have an intelligent answer to that question because I'm not familiar with Duo.
Sure, sure. Yeah, yeah, absolutely. Sometimes the best answer is, we don't know. And that's what you have to hear. So Khan wants to know, and I will avoid saying Khan in Star Trek voice, but Khan wants to know, uh, how would we use PowerShell to monitor for multiple rapid failed logon events?
There are any number of ways that you could do that. Keep in mind that the example that I showed on the slide was really simplistic, that focused on one particular machine. What you would want to do, and if you wanted to find if there were multiple rapid fire failed logon events using PowerShell, is first you would need some sort of log file aggregation solution to where you're bringing all your log files to one place, or you've designed your script to look simultaneously across multiple servers. Either approach will work. The other thing that you're going to want to do is schedule that strip or that script using a Windows Task Scheduler so that it's running on a very frequent basis. You're not having to manually go in and run the script to check for failed logons. And then the third component that you're going to have to build into that script is some sort of alerting mechanism because you're not going to sit there and watch your console all day long to see if PowerShell comes up with something. It's going to be a lot more effective to design the script so that if the failed logins that it detects meet a certain threshold, maybe there's a certain number of failed logons within a certain amount of time, then it notifies you, whether it's by email or by pop-up message on your console or some other mechanism.
Okay, great. Hey, Brian, I think we're going to have to leave it there for today. Thanks so much for putting together this presentation. Absolutely fascinating and just critical stuff that we all need to know. We really appreciate your time today.
Hey, thank you so much for having me.
Okay, so that is before we wrap up today. We do have one more piece of business, and it's the Amazon gift card prize drawing giveaway. And without any drum roll, which I don't want to do on my desk here to hurt everyone's ears, the winner of the $300 Amazon gift card is Blanton Hardy. Congratulations. Blanton Hardy is from Alabama. Sorry. Congratulations to you, Blanton. We'll be in touch very soon to get you your gift card. And with that, on behalf of the Actual Tech Media team, I want to thank our sponsors for making this event possible. Again, those sponsors today are Veeam, Rubrik, and CyberArk. And thanks as always for attending and for your great questions. It was a real pleasure to be on with you today. That concludes today's event. Have a great rest of your day, everyone.